Welcome back, students. During our previous class, we have studied about Newton's law of gravitation, and I have discussed about in detail what the Newton law of gravitation is, and what about the difference between value of small g and capital G. What the g is, small g stands for its expression due to gravity, and what does the capital G stands for? It is universal gravitational constant. The values of both are the different, units are different, one is varying, other one is constant. So these are some of the points to remember whenever you are asked to find out the difference between the two, you will be able to differentiate. So following the same chapter, that is gravitation. Now today we have a third lecture. In this lecture we will study about the mass of the earth. So you know that one of the most important object of application of the Newton's law of gravitation is if you are given object mass of one object, then you can calculate the mass of another object by using that formula after putting the value of constants, that is g, in the formula. So to calculate mass of the earth, again we follow the Newton's law of gravitation, and in this law here two masses. One is the mass of the earth, other one is the object of the mass m placed at the surface of the earth. These two masses are at a distance r from each other. So RE is basically stands for the radius of Earth, because when you have taken the radius of the Earth, this shows that this is the distance between the center to center of two objects of the bodies. You know, if this one is mass of the Earth, this one is mass of the body. You have placed any type of the mass at the surface of the Earth. It will be at a distance r from the center. Now you are not adding the center of this mass, because if you compare the radius of the Earth, it is very, very, very small. So that for simplicity, we consider the distance between the two bodies, that is equal to the radius of Earth. When you apply, if you look at this one, basically you are applying Newton's law of gravitation, and it is this force of gravitational force is directly proportional to product of masses. Means ME and ME, M is the mass of the earth. You can also label with MB. This is the mass of the body. They are separated at a distance RE. So you apply Newton's law of gravitation. Let's see. Consider a body of mass m. This is explanation. Is placed at the surface of the earth. The mass of the earth and the radius of earth are ME and RE respectively. This ME is basically mass of the earth, and this RE is basically radius of the earth. So, and these are separated at a distance RE. Our topic is to calculate mass of earth by using gravitation, Newton's gravitational law. The statement is this one, and you will, if you write only the difference is with the masses, F directly proportional to ME, M, mass of the body, and then the square of the distance between the two, that is RE. Now, if you proceed the next, this force acting between the two bodies is basically the mass, weight, and weight is equal to mg. Here is the value of the force, and if you look at the gravitational law, basically by using Newton's law of gravitation, you have used this one is two masses, m, mass of body, which is placed at the surface of the earth. This me is basically mass of the earth. This re is the distance between the center to center of these two masses. We don't consider the mass of smaller object because it's too small as compared to the radius of earth, as compared to the other objects. So that's why it is not considered. Directly the distance between the two objects is radius of earth. So if you simplify it, your one mass is cancelled with the other one, and then finally you are getting g is equal to gmb divided by r square, and this mass of earth is calculated by using this formula. If you put the values of these constant, that is radius of earth, value of small g, and gravitational constants, these all are given, values are given. If you put the values of all the constants, you can calculate the mass of earth. This is the formula. This is basically radius of earth, this is value of g, and this is value of capital G. You have placed the values of all the given uh, unknowns. So you have placed the values, and after placing values, you have done some calculation, and after calculation, you will get mass of the earth, that is 6 multiplied 10 to the power 24 kgs. So that is the mass of the Earth if you see uh, in kgs, and then you can also calculate in grams as well. At the end of the topic assignment, how can we calculate the mass of the Earth? This is one question. Number two, what is the value of mass of the Earth? And then what is the value of mass of the Moon? You have to calculate the mass of the Moon. And you have to remember the values of all these three given objects. That is Earth, value of mass of Earth, value of the Moon. I thank you all for your patience. During next class, we will study more about gravitational force.